Hey everyone, thank you for joining. I don't know, I can see some people in the back of the room. If you can move forward, but thanks everyone for joining. I'm really excited to be here. I know this is a bit of an alternate format, so I have to apologize in advance. My travel plans, I couldn't get there, but I've got some serious FOMO. I've heard some great things about the event so far, and I think with all that excitement, nothing can get you more excited than technical debt, right? At 3 o'clock in the afternoon, this is exactly what people want to hear about. Your sugar level. Hopefully, you got something outside. But I would have loved to have been talking with you in the halls, introducing people, and really getting to know everyone there. It's a great talk we're going to do now. I think this is probably one of the most demoralizing topics that we are saddled with as developers. And yeah, I can imagine you all leaning in, getting really excited. But thanks a lot for being here. And sorry about the setup here. But I can tell you, right, in all seriousness, there's not a single person in this room who is not affected by this growing burden of technical debt. And for any reason, if you happen to be in a large institution and you somehow avoided this upgrade pain and you don't have this problem, raise your hand because I'm sure a bunch of people in the room will be sending you their CVs. They'd much rather be working in a place like that. So today I want to talk about, with Jonathan, real actionable opportunities to tackle this problem, not in isolation, but together, through open source. And this is not just aspirational, this is actually happening. So first, I want to give a little bit of context, kind of the challenges we're up against and what's changed recently. I then want to hand it off to Jonathan Schneider, you see on stage, the co-founder of Moderne and the creator of an open rewrite framework, which has really become an ecosystem for changing code at scale, to share what he is seeing on the front lines of software refactoring. And then finally, I want to close the session and have all of you leave energized to find real ways for us to work together, because there's no reason we should be doing this alone. So let me start with a personal tech debt story. During COVID, in I guess 2021, Microsoft asked me to present at their Build conference, and right at the very end of that, they told me I can't use a virtual background. This was at the time we were all doing things remotely, and so the only problem was I was doing a mega refactor in my house. I had literally started a gut renovation, and this reminds me of just like trying to keep your software up and running while you're doing a major refactoring, and that's hard. So they asked me to go without a virtual background. I quickly cobbled together a bunch of things to make it look like I've got a background. You see on the left, this is the Microsoft screenshot that actually came out in their production studio in Seattle. And on the right, this was the background I put together. But what was going on behind the scenes, and this is like what I kind of look at this and say, this is what our software stacks looks like. This is what was going on behind the scenes. Like, I totally MacGyvered up the situation. I had taken a door frame from somewhere that was thrown away, and I cantilevered some spotlights. There were no lights in my ceiling. There was no paint on my walls. This bookshelf was like meters away from where it's supposed to be. I had everything kind of propped up. But I'm using this as an example, but this really reminds me of what it feels like to be trying to do major changes, like changing the engine while the plane is flying, trying to do major changes in your software while you're also trying to stay up in production for your business. So with that, I want to set the stage and talk about this problem to really, set a backdrop for how we try to tackle this differently than we've done before. And that's important because there's new ways to do it now. And we're all sitting in a room with an organization that's allowed us to collaborate with each other. I think we can all agree that fixing older versions of things and tackling breaking changes is not really a source of competitive advantage. And so it's one of those things that's very, very intuitive that we should be collaborating through open source. So let's just dive right in. I think we all know about technical debt. Most of the people in the room, if not all, are technical in nature. The problem was described in a Wall Street Journal article as a $1.5 trillion problem. The scale is big. We keep growing the amount of repositories we have, tens of thousands of repos. The code just keeps growing. We never kind of shut things off. And as that happens, we continue to accumulate problems that aren't really our own fault, right? The open source community is deciding to change stuff, and we're stuck there trying to deal with those changes. And we can't upgrade certain things because they're not compatible, and we didn't choose to pick a certain combination of things. The stakeholders just want to see the green button that they will get new business from a new client. They don't really fully understand and appreciate the challenges we have around the upgrades that we need to do. And therefore, over time, this becomes more and more problematic. It starts competing with our book of work. It's also important, from a supply chain risk perspective. And I know both within FINOS and in other organizations like OSSF, sorry, there is a lot of focus on supply chain security. Why does it happen? We know, right? The competing priorities I already spoke about. We have an evolution of needs, right? Things start off one way and then they drift from their initial purpose, and suddenly they've accumulated all this unnecessary functionality. There's also the complexity of the problem, right? Sometimes we're too enabling to our developers and we're not opinionated enough. And as a result, 1,000 different things are being used. Other times we're too opinionated and we made the wrong choice and we're stuck on something that has no future. In fact, some of the projects that we've been talking about in the board level with FINOS are things we need to take on because the community has kind of abandoned them or changed direction. What do we do with all that stuff we're supporting? And so these problems continue to happen, right? How do some large organizations deal with this problem? In some cases, again, if you're an opinionated stack, you're telling people you got to use this. We've got a central choke point to all of our third-party dependencies. As long as you're in the stack, you're good to go. And that's great where that happens. In some cases, there are motivated development teams. This is like the best opportunity where teams take it upon themselves to make these upgrades. They do a fantastic job. They dedicate 1% of their capacity. They're fairly mature in this discipline. All is good in the world. I'd say that reflects the minority of teams in large enterprises, but it is an existent one. Then you've got this other thing, which I call the F word, factories. You hire these pools of consultants, and they come in and do this dirty work for you, one repo at a time, and just send you off some PRs. And those PRs are good for that one upgrade that you did that one time in that one situation. They don't scale. It's a waste of money. It's great because if you're spending money on that, it's a perfect budget to use towards thinking about the problem differently. So it's great. If you're already doing that, and I know many companies do it, there's your budget for anything better than that. But that's definitely something that we do see. And then, of course, alongside of all of this, there's the central team that helps kind of catalog the problem. You have a whole bunch of these things. They're accumulating at a regular pace. You're kind of dealing with the smallest set of them first. And that hygiene team, whether it's called a hygiene project or a tech debt reduction project or a supply chain security project, you're usually prioritizing and reprioritizing the things that you absolutely have to do to kind of keep that list manageable, because tackling it all doesn't scale and it's growing way faster than it's shrinking. And so that's kind of what we're dealing with overall. But what's changed? So this is the way we've always been doing it. This is what I think many of the large enterprises have encountered. But I realized, so what's changed now? Why am I talking about it today? And how do some of these changes affect us? So a couple of things have changed that have accelerated the problem, that have also brought us some new solutions. So we know that these central factories don't scale. The technical debt, you could see the Stripe developer coefficient. Sorry about the font under there. I don't know what's going on there. The developer coefficient that they did a report, the amount of time we're spending worried about tech debt and upgrades is taking a larger percentage of the total amount of time we're doing development. And as I said, this is demoralizing. I don't know why you're listening to it now. It's probably a therapy session for many people in the room. This is painful. We don't like this. The worst part, or the better part, the tools are getting better. Everyone's proud of these tools. They're finding more stuff to do. So it's great that they're getting better. It's creating more work. The bespoke solutions that we try to create aren't as cost or resource effective. The factory is a good example of that, but then there's some others as well. We're asked to move faster. We're asked to modernize more. We want to use new things like AI and use all the latest libraries, and we can't because we're on this older version of some framework or some runtime that's just holding us back. The end, this tech debt is growing, and it's growing faster, half because open source libraries are choosing their own paths and we're stuck dealing with it. And then the other half because the tools are getting better at telling us we've got more work to do. It's clearly getting a lot more attention, right? OpenSSF, this has been a theme at FINOS for many years. The focus on the software bill of materials, the SBOM, everybody wants to know what you're using, where you're using it, and when there's a problem, how can you get rid of the places you have it as fast as possible, right? The Federal Financial Institution Examination Guide put out updated guidance, and they're starting to talk about end of life. They never did that before. This was an update that was made, I think the last update was 2 decades before. And so this is clearly becoming a bigger focus. So that creates more work for us and more senior leadership attention on the work that we're doing. And then you got the other stuff, right? I'm not going to mention names of systems or frameworks in the room. Not that you're in the room, but like, I'm not going to mention any here, but there are license rug pulls where the license changes. And as a result of that, you now have to either run for the hills or change your behaviors to deal with the fact that you're on stuff that can't be fixed if it breaks and things break. When you're on something old, it is like an increasingly growing surface area of problem and all of its dependencies and so on and so forth. There's a narrower end of support window for these libraries and for some of the vendors. As I said, the frameworks are changing. The author of the framework decided, hey, it's really cool to use X. Guess what? X is forbidden from our license scan, and suddenly this library is off limits. Now we're on like a collision course with Doom because we can't go to any further upgrades of that library. We got to find something else. There's also alternative libraries, right? Remember the day when Angular looked good until you saw React, and then someone said Vue, and then someone said something else, right? They keep coming. There's a constant need to change, and that innovation is happening faster. And as I said, the vulnerability rate is being increased in terms of discovery. There's also, on the good side of this, there's an influx of new tools, like very many of them, right? Obviously, you've got the Dependabot and version bumping tools, fantastic. You've got them, with some code changes. You've got them with just dependency changes. You've got, very specific scripts like code mods for JavaScript, some stuff for .NET that are helping you do script changes of specific languages. Usually they're fairly simplistic. They can't really deal with the guts of your crazy code, but they do some stuff. You've got new frameworks that can execute your changes at scale and be highly precise with what they do. Open Rewrite is one of those examples. There's others. There's Gen AI stuff. How many times do you see someone talking about what they're going to try and do with a Gen AI solution when you could have just edited a line of text yourself? There are times for everything, and you're going to need to use everything. But I think overall, the real challenge is trying to make sense of this to your management to say, hey, I need to do this differently now than I did it 5 years ago. 5 years ago, you had the person with the clipboard and the hygiene list telling you, what do you think you can get done by Q1? Let's negotiate pushing this off till Q3. And everybody knows when you set a date to Q4, that means we're not doing it, right? I'm not going to go there. No, I don't believe in Q4. Q4 is like not a real time, a time span. But this goes on. And so the first thing you need to do is kind of size up the problem space, size up the opportunities, and start to think about different combinations of tools that you want to use to tackle this. So here's how I kind of sized it up. You've got the challenges where you talk about all the stuff we spoke about until now. You've got a bunch of different tools. Some manipulate text, some just do version bumps. Some are your Gen AI code assistants. Maybe they're good for a local workspace. They're good for a repo. Then you've got two directions to go in that are kind of like the fundamental, I'll call them game-changing spaces. One, can you programmatically refactor code as precise and accurate as you would a compiler or something else? So can you do something like that? Or do you need to reimagine your stack using a different programming language or trying to re-architect something using a completely different framework? Maybe you want to move from Spring integration to Apache Camel to something else. You want to re-architect your application altogether, right? There's times where you need to go with Gen AI. It's really creative. It's good. It makes mistakes really quickly and does it at scale, which is brilliant. Overall, it's good at those really creative processes that you need to get over the 40% line to justify spending the rest of your Friday on it. But when it's time to do a lot of code and trust that code across thousands of repos, I even heard a company that's dealing with millions of repos now, which is a frightening thought, or over 1 million repos. But if you're trying to do that, then that is not going to scale. Gen AI will not scale for you, nor do I think it'll give you anything useful. But it will give you some really useful things along the way. Programmatic refactoring, if we could do that, we can upgrade, let's say, a major framework version with a bunch of breaking changes at scale across a bunch of repos with a high degree of accuracy and a high degree of trust. So really, you need to take this entire landscape of tools, recognize, A, you're going to need a combination of these tools, and B, you need to know what to use for what. And only then say, okay, we've got this set of problems. We've got this set of tools. A lot of this stuff is in the open source domain. How do we sit down as a community and try to tackle some of this together so we can all move faster with this and move on to the work we actually want to do? So this is a table I put together. I'm not going to read the whole table, but I wanted to just share it with you, and you'll have the slides afterwards. It's basically a way to talk about a bunch of different tasks and maybe which ones are more suitable for scaling solutions that work on cheap compute and are relatively deterministic versus non-scaling solutions, which are much more the creative side. I don't know if that's the right or left side of the brain. I'm not even sure. But the non-scaling solutions are great and essential. Your management's you need to ask them at some point for budget to invest in this stuff. Maybe it's after you collaborate with peers through FINOS. Maybe you're already there, but you need to recognize quickly you're going to need more than one solution. It's going to be a combination, and you're going to need to know what to use for what. And so this is the backdrop where I wanted to kind of bring us up to the point where Jonathan can take us forward and talk a little bit more about what he's seeing both in the open source industry as an open source veteran, what he's seeing in the use of the open rewrite framework, and then also what he's seeing from big enterprises like us that he deals with on a regular basis. So Jonathan, I'm going to hand it over to you now.
Yeah, my name's Jonathan Schneider, and I founded the Open Rewrite framework back at Netflix almost 10 years ago now, so way before the Gen AI era. I was working on engineering tools, which was a central team. One of our tasks was really to try to help keep the organization moving forward. We had, I think, 10 to 20,000 Java microservices at that moment, so just Java version updates, Spring updates, so same kind of stuff we're still dealing with today. Interestingly, they had that freedom and responsibility culture there, which meant as a central team, I couldn't impose any constraints on what product engineers did. I couldn't say, hey, on a certain date, if you're not on this version, I'm going to break your build. That would be anti-cultural. So I spent a lot of time, like most of us in that era, building reports and kind of like internal developer portal sort of things, trying to surface context developers about where they were relative to where we wanted them to be. And that resulted in approximately 0 action or movement on the part of the product teams. If we would talk to them and say, what could I do to make you move forward? They would always answer me very sarcastically. They'd say, do it for me. Otherwise, I got something else to do. And so really, it was hearing that enough times. If you're not too stubborn, you start to think, how do we do this for them, right? How do we try to craft this change for them? And so that's really where Open Rewrite was born. That same freedom and responsibility culture that drove me to automated refactoring as a thing also, led to a high degree of inconsistency internally inside the Netflix code base, all over the place on build tools, on versions of things, on styles, just everybody chose their own thing, right? So it was, in many ways, it's kind of the antithesis of what we think of as like a Google or somebody that has a monorepo with a very consistent style. It was kind of all over the place. I put that aside. I went to the Spring team, spent a few years with my co-founder here in front of me, Olga Kunzic, working on continuous delivery. We were working with JPM, we were working with Fidelity, many organizations like that, trying to teach continuous delivery, and we saw them all struggling with this same problem of moving forward. Interestingly, while many organizations like yourselves may think of yourselves as different from Netflix, you're actually very close to the, you have that same characteristic of a lot of different teams, many years of different code, so a lot of different patterns in use. And so the same kinds of solutions that I was working on for Netflix actually had a high degree of applicability inside of this organization. If you haven't seen Open Rewrite before, I'm showing one change up here. This is a migrate to Java 21 recipe. What it does is it runs programmatically and deterministically to make a code change to accomplish some objective. So this is, I'm trying to move a bunch of code to Java 21. The recipe, we call these recipes, they're programs that make changes. These recipes are going to go through and prepare the change for the developer. And what I want a developer to do at the end of the day is commit. So I'm not going to do it. I'm going to kind of get them all the way to the very end and then say, now you take responsibility for committing this. Recipes themselves become deeply nested and composite. So this is just one Open Rewrite recipe to do a Spring Boot migration. And you'll notice to migrate to Spring Boot 3.4, I first have to get to 3.3, which means I have to get to 3.2, which means you have to get to 3.1, which means you have to 3.0, which means I have to migrate to Java 17, which means I have to get to 11. I have to do JUnit 4 to 5 migration. I have to do Mockito 1 to 3. I have to do Spring. So you get, right, like this, there's 3,400 steps to date in this one migration. And really, that's what we're asking developers to know when we're asking them to do one of these large upgrades. As a community, Open Rewrite being open source at its core, we've seen contributions of recipes from kind of all over the place, from framework authors themselves, from end users of these frameworks that really can't wait for the framework author to provide a recipe. So it's a collaborative effort across industries and across, frameworks and so forth to try to fill in the gaps for providing these recipes. Many of the recipes, I wouldn't say a majority, but a good healthy number of the recipes here in the Spring Boot 3.x migration actually came from JP Morgan, one of your member organizations, because they have tens of thousands of repositories written on top of Spring Boot. This is a high pain point for them to migrate from one version to another. The other thing, the pattern that works most effectively at applying these kinds of changes across large business units is when you don't take the perspective that a central team is going to mass issue pull requests to every sub-organization and sub-team and expect that those teams will just merge. I kind of have this analogy. It's like receiving a PR from an external team can be like receiving unwelcome advice from an in-law. You're just looking for a reason to reject it. If you give that advice to yourself, you just have a tendency to want to accept it more. So we focus really on how do we get a team, in a room, ready to go to do this migration, to look at it together, and to try to plan out how much of it they want to accept and in what steps. And the most effective teams are the ones that, if it's a higher risk, or more risk-averse team, they'll just take a smaller unit of work and they'll say, I'm just going to do this piece first. I'm just going to do the Java 17 migration, or maybe I'm just going to introduce Gradle and Maven wrap or something like that. And then I'll get that to production and I'll come back and run a larger recipe and a larger recipe, and in pieces I'll get myself there. And if you can take teams through that journey and really give them credit for what they're doing, for the commits that they're making, for additional recipes they're committing, that's really what leads to a healthy dynamic, I think, between the really kind of central driving force of a change and all the individual product teams that are affected by it. These recipes, at this point, there's thousands of these. They've just come from all different areas. Recipes themselves are, can produce impact analysis, or they can do searches and produce data. And we're increasingly finding the data that these recipes to emit to be building blocks that we can surface as tools to large language models to understand large code bases. And so, just kind of one experience here that we're thinking about is how do I kind of do the same thing that we do with coding agents, but with, across whole business units? Like, what version of Gradle am I using? How would you answer that question? The model's going to look for a correct recipe. It's going to look at its description. It's going to learn how to use it. It's going to look at the data that it emits. It's going to run that. It's going to get that accurate data back. And then it's going to be able to summarize holistically across a whole business unit, where I'm at right now. So to the extent that we collaborate together to provide net new recipes that speak to this group's unique concerns, and I'll mention one here in a moment, those recipes can act as tools to a model to really execute this across hundreds of millions of lines of code. So one kind of financial services specific example that came up recently was actually from JPM. They were working on post-quantum cryptography and trying to find patterns in code that will be vulnerable to in a quantum world. They had identified 12 patterns in code. We had written a series of recipes to go find those patterns and really try to find them not in a false positive, like in an accurate way. If I'm looking for hard-coded protocols or algorithms, I'll see code like get instance, but there's a lot of receiver types of get instance, right? So the data that backs Open Rewrite is able to accurately identify get instance calls specifically on the security type, which gives us, kind of an accurate picture of where this pattern exists in a large code base. PQC, or post-quantum cryptography, is obviously a use case that's applicable to all of us here. So this is just, I think, one example of something in the evolution at scale working group I'd like to see us collaborate on together to put us in a safer position in a post-quantum world. Dov, I know you have some other examples, and I'm happy to turn it back over to you here with the few minutes we have left.
That's great, Jonathan. Thank you very much. Yes, so I want to do this as a call to action, as well as spit out some examples, as Jonathan alluded to. This is one really useful technology. There may be other open source ways to collaborate together, but I want people to leave here energized to find ways to work together on this problem. It's not a problem we should work on together. So what can we do, right? It's not competitive advantage. We can tackle these together. We can collaborate through FINOS. We can also be the collective voice of the industry to our vendors and their partners and people that were like, come to us with a solution, not a problem. You want to get breaking changes through the environment, use a recipe. Give us the recipe to write, to help us run those changes through our environment, or whatever technology. Don't just leave us hanging there with a bunch of work that we all have to do independently of one another with no creative thinking of how to do that work. So we really need to get them involved in this. And that's also a great way, if we can collaborate with the vendors, with the third parties as financial institutions, we can also do that through FINOS. Examples that came up when I was talking with others, both within, in the conference setting like this, as well as earlier, right? We've got, dependencies of the FINOS repos themselves. I think for open source repos, the platform that Jonathan built on top of Open Rewrite is free. And I think the FINOS organization is already can ingest it in there to play around with. So anyone can go back to their desk, and probably at the Moderne booth, you could see that stuff in action and try it out. Explore this also for common controls. One of the common things I've seen when speaking to people is going through your Kubernetes files or your CloudFormation and being able to apply controls consistently across all the files in your repos, all the files in your estate. So maybe we use that as a way to apply the common cloud control stuff that we're working on. You may want to use it to maintain as API providers, whether it's CDM, whether it's FTC3, how we keep people up to date on the use of those things through creating a recipe that corresponds every time we do a breaking change, creating a recipe of some sort that moves you from FTC spec 1 to FTC3 version 2, or the next version of the spec. And then also there's just being able to, in an open way, share experiences of what we're dealing with, how we're dealing with this problem, both the AI tools that we use and the non-AI tools we use. A safe place for us to do that in of itself is of value, even if we're not actually cutting code and sharing with each other. So we have a working group called Evolution at Scale. One of the co-chairs, I'm assuming, is in the room, definitely at the conference, Miguel Gasca. There's another co-chair in Montreal. And then there's a bunch of people that are meeting on a either biweekly basis to discuss this issue and create the opportunities that we want to be able to work on together. I encourage you, unless people raise their hand at the beginning of the presentation with no tech debt challenges, every member organization at FINOS should probably be sending a delegate there and figuring out how we can collaborate. So that would be my call to action to people here. Identify the open source stuff we need to boost maintenance efforts around as an industry, as well as work together on what we need to tackle. You can scan the QR code to get to the URL that's below it. And I encourage people to spend time talking to Jonathan, Olga, others there, Miguel, anybody who's around that can talk about this. I really think we have a great opportunity to work together. And I hope that we'll have that opportunity and see this really flourish in the next year. So thanks everyone for your time.